Hi, my name is Ruben Augustus, UR15CS108. Today we will be seeing Data Structures Lab Experiment number 3, queue implementation of an array. So here we have hash include, we include the header file and we use standard namespace, and we have int data for storing when we get the value from the user, and int n just to store the size of the array, and I have a queue for storing 5 values, and I've initialized I've initialized front and rear to -1, and here we have 3 integer functions, enqueue, dequeue and display. We'll be calling them later. And here int choice is the variable I've used to get the choice from the user, and here we have the menu enqueue, dequeue, display and exit. We get the choice from the user here, and in this switch case it's very simple. We have case 1 enqueue, case 2 dequeue, case 3 display. Straight away we just call the functions here, enqueue, dequeue and display. And here go to read this function is used after every function executes. It goes back to here and the menu gets displayed. That's the main purpose of go to read. And here for exit I've just used a break. I've not used a go to read, and so it just say thank you and exit. And again here default function, so if you just default case, if you just input a wrong value. So in the enqueue we have the first if condition. We check if the rear is equal to n-1. That's the maximum value -1. So if the queue is full, we inform the user that the queue is full. Otherwise we increase the rear value by 1, and we get the value from the user here, and we store it in the rear. So, and then if it's the first value that we're inputting, the front will be -1, so we increase the front by 1, so it's 0 here. So in the dequeue function, here we check if the stack is if the queue is empty. So if the front is equal to -1, that means the queue is empty. And here the data, we get the value from the user. We get the data which is stored in the front, and because in a queue the value goes out from front, so we initialize that space to 0. And if the front and rear are the same thing, we remove the value. That means the front and rear are in the same position. That means that it's the last value, so we initialize both of them to -1. Otherwise we say we increase the front by 1, and we remove the data. First we display the data, and then we delete the data. So here for the display function, current queue, we just say current queue is equal to, and we display whatever values are there in the queue. So let's see some inputs and outputs. So first I just input 5 values. 45, 55, 65, 75, 85 and 90. So it says the queue is full. So now let's dequeue some values, or let's check the values in the queue first. We go for the display 3. So we have all of them in order: 45, 55, 65 and 75. So let's take out some values. So we've removed 45, and then now let's remove one more. We've removed 55, and let's remove another. We have 65. So now let's see how many values are there in the queue. So 3. So we just have 75 and 85 in the queue. So let's exit them again. 2 and 2. So now we should say stack underflow. Queue underflow. Queue is empty. So let's try to display again. 3. It says current 3. So thank you. Now let's just exit.